This is a LibriVox recording. All LibriVox recordings are in the public domain. For more information or to volunteer, please visit LibriVox.org. Recorded by Julian Jameson. The Concept of Nature by Alfred North Whitehead. Section 8. Summary. There is a general agreement that Einstein's investigations have one fundamental merit, irrespective of any criticisms which we may feel inclined to pass on them. They have made us think. But when we have admitted so far, we are most of us faced with a distressing perplexity. What is it that we ought to think about? The purport of my lecture this afternoon will be to meet this difficulty, and so far as I am able to set in a clear light the changes in the background of our scientific thought which are necessitated by any acceptance, however qualified, of Einstein's main positions. I remember that I am lecturing to the members of a chemical society who are not for the most part versed in advanced mathematics. The first point that I would urge upon you is that what immediately concerns you is not so much the detailed deductions of the new theory as this general change in the background of scientific conceptions, which will follow from its acceptance. Of course, the detailed deductions are important, because unless our colleagues, the astronomers and the physicists, find these predictions to be verified, we can neglect the theory altogether. But we may now take it as granted that in many striking particulars these deductions have been found to be in agreement with observation. Accordingly, the theory has to be taken seriously, and we are anxious to know what will be the consequences of its final acceptance. Furthermore, during the last few weeks, the scientific journals and the lay press have been filled with articles as to the nature of the crucial experiments which have been made, and as to some of the more striking expressions of the outcome of the new theory. "Space caught bending" appeared on the news sheet of a well-known evening paper. This rendering is a terse but not inapt translation of Einstein's own way of interpreting his results. I should say at once that I am a heretic as to this explanation, and that I shall expound to you another explanation based upon some work of my own, an explanation which seems to me to be more in accordance with our scientific ideas and with the whole body of facts which have to be explained. We have to remember that a new theory must take account of the old, well-attested facts of science just as much as of the very latest experimental results which have led to its production. To put ourselves in the position to assimilate and to criticize any change in ultimate scientific conceptions, we must begin at the beginning. So you must bear with me if I commence by making some simple and obvious reflections. Let us consider three statements. 1. Yesterday a man was run over on the Chelsea embankment. 2. Cleopatra's Needle is on the Charing Cross embankment. And 3. There are dark lines in the solar spectrum. The first statement about the accident to the man is about what we may term an occurrence, a happening, or an event. I will use the term event because it is the shortest. In order to specify an observed event, the place, the time, and character of the event are necessary. In specifying the place and the time, you are really stating the relation of the assigned event to the general structure of other observed events. For example, the man was run over between your tea and your dinner, and adjacently to a passing barge in the river and the traffic in the Strand. The point which I want to make is this: nature is known to us in our experience as a complex of passing events. In this complex we discern definite mutual relations between component events, which we may call their relative positions, and these positions we express partly in terms of space and partly in terms of time. Also, in addition to its mere relative position to other events, each particular event has its own peculiar character. In other words, nature is a structure of events, and each event has its position in this structure and its own peculiar character or quality. Let us now examine the other two statements in the light of this general principle as to the meaning of nature. Take the second statement. Cleopatra's Needle is on the Charing Cross embankment. At first sight, we should hardly call this an event. It seems to lack the element of time or transitoriness. But does it? If an angel had made the remark some hundreds of millions of years ago, the earth was not in existence. 20 millions of years ago there was no Thames. 80 years ago there was no Thames embankment. And when I was a small boy, Cleopatra's Needle was not there. and now that it is there, we none of us expect it to be eternal. The static timeless element in the relation of Cleopatra's Needle to the embankment is a pure illusion, generated by the fact that for purposes of daily intercourse its emphasis is needless. What it comes to is this: amidst the structure of events which form the medium within which the daily life of Londoners is passed, we know how to identify a certain stream of events which maintain permanence of character, namely the character of being the situations of Cleopatra's Needle. Day by day and hour by hour we can find a certain chunk in the transitory life of nature, and of that chunk we say, "There is Cleopatra's Needle." If we define the needle in a sufficiently abstract manner, we can say that it never changes. But a physicist who looks on that part of the life of nature as a dance of electrons will tell you that daily it has lost some molecules and gained others, and even the plain man can see that it gets dirtier and is occasionally washed. Thus the question of change in the needle is a mere matter of definition. The more abstract your definition, the more permanent the needle. But whether your needle change or be permanent, all you mean by stating that it is situated on the Charing Cross embankment is that amid the structure of events you know of, a certain continuous limited stream of events, such that any chunk of that stream, during any hour or any day or any second, has the character of being the situation of Cleopatra's Needle. Finally, we come to the third statement. There are dark lines in the solar spectrum. This is a law of nature. But what does that mean? It means merely this: if any event has the character of being an exhibition of the solar spectrum under certain assigned circumstances, it will also have the character of exhibiting dark lines in that spectrum. This long discussion brings us to the final conclusion that the concrete facts of nature are events exhibiting a certain structure in their mutual relations and certain characters of their own. The aim of science is to express the relations between their characters in terms of the mutual structural relations between the events thus characterized. The mutual structural relations between events are both spatial and temporal. If you think of them as merely spatial, you are omitting the temporal element, and if you think of them as merely temporal, you are omitting the spatial element. Thus, when you think of space alone, or of time alone, you are dealing in abstractions. Namely, you are leaving out an essential element in the life of nature as known to you in the experience of your senses. Furthermore, there are different ways of making these abstractions which we think of as space and as time, and under some circumstances we adopt one way, and under other circumstances we adopt another way. Thus there is no paradox in holding that what we mean by space under one set of circumstances is not what we mean by space under another set of circumstances. And equally, what we mean by time under one set of circumstances is not what we mean by time under another set of circumstances. By saying that space and time are abstractions, I do not mean that they do not express for us real facts about nature. What I mean is that there is no spatial facts or temporal facts apart from physical nature, namely that space and time are merely ways of expressing certain truths about the relations between events. Also, that under different circumstances there are different sets of truths about the universe which are naturally presented to us as statements about space. In such a case, what a being under one set of circumstances means by space will be different from that meant by a being under the other set of circumstances. Accordingly, when we are comparing two observations made under different circumstances, we have to ask, do the two observers mean the same thing by space and the same thing by time? The modern theory of relativity has arisen because certain perplexities as to the concordance of certain delicate observations, such as the motion of the earth through the ether, the perihelion of Mercury, and the positions of the stars in the neighbourhood of the sun, have been solved by reference to this purely relative significance of space and time. I want now to recall your attention to Cleopatra's Needle, which I have not yet done with. As you are walking along the embankment, you suddenly look up and say, "Hello, there's the needle." In other words, you recognize it. You cannot recognize an event, because when it is gone, it is gone. You may observe another event of analogous character, but the actual chunk of the life of nature is inseparable from its unique occurrence. But a character of an event can be recognized. We all know that if we go to the embankment near Charing Cross, we shall observe an event having the character which we recognize as Cleopatra's Needle. Things which we thus recognize I call objects. An object is situated in those events or in that stream of events of which it expresses the character. There are many sorts of objects. For example, the colour green is an object according to the above definition. It is the purpose of science to trace the laws which govern